Hello everyone, I am Ahmed Nobi. I am a teaching assistant at the Architectural Engineering Department at Asyut University here in Egypt, and this is the graduation project of the KITEC BIM Application Development Diploma. This add-in is called Coordination Checker. First of all, the content of this presentation is the introduction, the add-in overview, the analysis, which includes the input, the algorithm, and the output, and the workflow, of course, which represents the software development lifecycle as much as possible, and the helping tools, difficulties and how I faced them, and of course the future enhancements. Problem statement. First of all, coordination is very substantial. It is of utmost importance in BIM workflow. So in order to enhance this coordination, a lot of concepts are there, such as the LOD or the level of development. However, they are very controversial and very complex. Some new approaches are called, one of them is called the status code concept, in which a parameter is assigned to each element in the model that represents the level of maturity of this exact element. Such approach, although it is better understood and customized to localized context, but it's overwhelming to apply because for each Revit document you have to create these parameters separately and create filter views and to override the views. However, this is not effective, and this is far away and actually goes in contrast with the BIM goals. The solution, however, is to create an Autodesk Revit Addin. It's a powerful tool that programmatically and automatically adopts the concept of status codes and can be altered to ensure scalability and generalization. Let's see the status code in action. And just for the sake of argument, let's just set up the file. So we will run as an administrator, and then we're going to set the password, which is included in the file submitted. Okay, install. So it's going to be installed, finish. Okay, it should be working fine. I'm going to test this add-in and see how it works. So when the Revit opens, there is a small window that pops up and tells us that the coordination checker add-in is loaded successfully. We're going to then choose a sample project, for example, this one. Okay, so under the developer tab, we're going to see all the four buttons. For example, if we try to export a report right now, it will tell us that no coordination view is found. The same goes for the update the coordination. So if we're trying to create a coordination view, then it will ask us, do you want to choose an existing view? Okay, let's say yes, just for the sake of seeing what is going to happen. And this is the view selection form. If you choose anyone and choose OK, a coordination view will be created. However, I don't want to do that because I want to create a view that is general. So if I press no, this one is created. So if, for example, I say now update the view, okay, elements are already updated. Okay, so we're going to choose this roof, this roof on this floor, maybe this floor as well. And then we're going to choose this to the CS 40, for example. And then those windows are CS 30. And then those are going to be 20, just for the sake of proving the concept, that's all. So if we get here and say update the view, no, we say okay, we say update the view, we're going to say no, and then the update is done successfully. So this is the new colors. If we say report and then browse, for example, the desktop, okay, export. Okay, so the coordinated. Okay, moving on to the overview of the add-in. It's simply an Autodesk Revit add-in. It will be designed, or it is designed to enhance the coordination workflow by enabling a seamless management and visualization of the maturity level of the project elements, as we saw in the past videos. The add-in did visually distinguish between elements based on their status code parameters, and that is created under the identity data, making coordination tasks more efficient and intuitive. The target audience, two main target audiences are there: the BIM specialists and modelers, and the BIM coordinators. For the BIM specialists and modelers, this tool will help them to understand the coordination phase of the project, inform their design decisions, and enhance their communication with the BIM coordinators. While for the BIM coordinators, it will enable them to easily inspect the maturity level of the elements, define their needs of information, and assign tasks to BIM specialists and modelers. The main features include four main things. First of all, it creates the status code parameter automatically, and then it visualizes the status code in a single 3D view, and also it can update this 3D view, and then export an Excel reports that are ready to be communicated with different stakeholders. For the analysis part, first of all, the input. The users need only to input the or to prepare the view that they want to add in. For example, if I'm an architect and I want to do this coordination view for the architectural elements only, then I will prepare a view with the architectural elements only. And then the add-in will ask me, do you want to choose an existing view to create a coordination view for? If I choose yes, then this window will pop up and I can choose any one and choose OK, and then the coordination view will be created. Otherwise, if I press no, then the add-in will create a general coordination view with all elements. Regarding the inputs only, we only need the path of the Excel file that the user would want to save it on. And then regarding the algorithm, first of all, the external application for the coordination view and the Visual Studio would be designed. We will make the application load the tab and panels. This is the developer tab and the panels. And then I designed some icons that represents what each one would do. This is the help for the guideline, this is the create, this is the update, and this is the export Excel report. First of all, the help external command, it simply opens a window to make the user familiar with the add-on. It tells the user what's the add-on, and this is the workaround here. When the user presses the guideline, the registered status codes that are already in the program are presented to the user to type it exactly the way he want to type it in the status code parameter. Each one of them represent some phase of the coordination. Those three are the main three: the the SC20, the 30, the 40. These are the four main, but those are more derived from those three. First of all, the elements are conceptual, meaning that the elements are preliminary. Their dimensions are not yet defined. They do not contain the necessary properties. And then from the status code 20 to status code 30, the internal coordination process happens, and then each element that takes the CS code 30 or is internally coordinated and ready for multidisciplinary coordination. And then the multidisciplinary coordination between various disciplines happens here between 30 and 40, and then the element would be ready as production underlay. This element is approved by the owner actually, or the consultant, and ready to be to extract highly detailed drawings for construction. The develop coordination view external command, for the create external command, we have 7 steps to take the user choices, either to create a coordination view from the user or a general one, and get all the elements in the 3D view, filter them based on their category, and remove elements that we don't want to, like the categories that do not allow binding, for example, and the elements that are not models, like the notation, for example, and then create a shared parameter file. It's a temporary file, and then delete it. Assign the default value of CS code 15 because it's the first one, which means that we are not sure which elements will be there and which will be removed. Then we will create the 3D view and name it coordination view using Revit API classes, and then override the graphics in this view. Regarding the update external command, the algorithm is simple. We will check if there is a coordination view. If there is not, ask the user to create one first. If there is, then check the status code parameter and check the colors. If there is no change, then tell the user it's all already updated. If not, then update it, and then tell the user it's updated successfully. The algorithm for the export Excel report is also simple. We will check for a coordination view. If there is not, we will ask the user to create one. If there is, then we will ask the user to, through a Windows form user interface, to enter the path and then check for the path and then save it using the EB Plus non-commercial libraries. Regarding the output, the first output is going to be the coordination view. This is an example. And then the sheet. The first sheet is the maturity level sheet, which consists of the categories, the families, the family type, the element ID, the element name, and the status code assigned to it. And this is the project info. And this is also similar with the charts according to one category. Regarding the workflow, this is the simple software development lifecycle that we or I try to apply as much as possible. First of all, the requirement phase or the planning phase. I wanted to make sure that it's very user-friendly and possible as much as possible, not just for the user, but also for the future developers as well. So this is the structure of the project itself. It consists of the folder of the Revit of the UIs, which is the forms that we use, the about form, the Excel report form, the guideline, the user guideline, the view selection form, and then there are the Revit external commands. And then there are the resources where the icons and images were there. First of all, we call the panel, the tab name and panel name, and we try to create it and catch any exception. And then in these 3 or 4 buttons, we create the buttons according to this function, which takes the icon and assign it to the button itself. Those are the buttons. For example, we create a class for the creating coordination view. We use the push button data. Then we create a new object from that and give it the names and the location and the external command to execute. And then you create a push button and give it the button data, and then using the tool tips, make it more of a small tip for the user to understand and get the image and put it in the large image. And this the same goes for the 4 other things. As a developer, I needed to identify what categories will be required to have the status code. So since I was trying to make it as general as possible, I had forsaken the idea that I had first, that the user should define the categories. And I decided that I will choose all the model categories that allow binding and where elements would not have a read-only property to the status code. In addition, also I excluded some categories manually, such as the materials, the project info, and etc., because those conditions didn't remove them. And I shifted my thinking so that the user can create a view with the elements that he needs, and then create the coordination view using the addon. Instead of just going through the categories and making him choose what categories to create a coordination view for. And also I decided that I wanted to create a temporary file for the shared parameter and then delete it automatically. This is because the Revit API do not or does not allow to create a project parameter and also open the door for future developments where the shared file can be used in other functions. So the analysis is the same as the one we presented earlier. This is the input, and this is the algorithm, and this is the output. For the design, I designed the structure, as I mentioned, also the previous or the requirement step. This is the Revit folder, which consists of the application or external application, the external commands, and the Revit utilities, which it's a middle class that handles between the Revit application and the Windows forms. And these are the Windows forms and also the resources files to put the images in it as the data that we want to show. First of all, this is the external command for the help. It's very simple. We call this window, this Windows form, in this external command, and then we just put in it the about form here, and the guideline form here. If the user pushes through any one of them, this will show up for the guideline. This will show up for the about the form, because to contact me as the main developer, and also to say that this is not legally used without my knowledge. Here we actually have a simple external command, which is the command that is responsible for creating the Windows forms for the user to understand the program. So we are simply calling the user guideline, which is a form, and then we are showing it to the user. In the guidelines, we are telling the user about the developer, which is me, of course, and we're using the label in this form. We're using the label text or the label link label, I think it's called. Yeah, link label to add my LinkedIn profile. And then in the user guideline, we are telling the users what is this coordination exactly. If the user clicked on the guideline, then we're going to show the user what is the guideline. We're telling him which status code to use for which case. And this is actually a workaround because the Revit API does not allow, according to my search and to my knowledge, does not allow for now, the setting of a parameter through a drop list of specific parameters. It doesn't happen through Revit API, so I think this is going to be also presented in the section of the feature enhancements if some features got updated in the Revit API. Okay, and then there is the create external command, which we first we want to introduce the Revit utilities class. In this class, we are identifying the data that we are going to use in the whole project. The document, the UI document, the application, the parameter name, the parameter group, the status options themselves, the temporary file path of the shared parameters, the colors that we are going to assign to the status options, the excluded categories that we excluded manually, the coordination view, and the coordination view name. Okay, so first of all, this is the external command that is responsible for creating the coordination view. We are first calling the Revit UI application and UI documents and documents because we're going to use them, and then we are using the try method and catch to catch any unhandled errors. And then inside the try, we are using the task dialog class to ask the user whether he wants to choose an existing view to create a coordination view from, or just create a general one, a new one. So if the user chooses that he wants to create or select a view first, then we're going to call the function or the class, the view selection class, which is created here in the UI folder. And then this form would show the user. It consists of just simple form consists of a list box views, and then we're going to put in here the views, calling them using the method here, which is we're going to load the views, and then we're going to put them in the list box views. So when the user does that and chooses them, then we're going to start our transition called apply coordination to selected view through two main steps. First of all, we're going to duplicate this view and add our extension to the name of the view that is selected by the user, and then we're gonna create the status code parameter using the temporary shared file parameter, and then creating the definition itself, and then we're gonna bind it to the selected categories through applying our conditions, the excluded properties, which is or the excluded categories, which is a property in the Revit utilities, manually handling some of the categories that we don't want to include. And other categories, we can exclude them through the allow bind parameter or bound parameter, and the category type to be manual. And then using this category set, we're going to bind our definition to it. And then we're going to set the default value to them by getting all the elements through a filtered element collector. And then we're going to try to use the get parameter definition and give it the definition, which is actually a rare usage to this overload of this parameter. However, the parameter, if it doesn't equal null, so we are handling the null reference exception, and if it is not a read-only parameter, so we are handling this error as well. And if it has a value, if it doesn't have a value, so we're going to use this to set the value to be the CS15, which is the default value, and then we're going to call our function, that our customized function to color the coordination view, which is a simple function actually. We're just getting the document, the view, the 3D view, the string parameter, and the dictionary, which is links between the status codes and the colors themselves. And then we are overriding, using the override graphic settings, we are overriding the solid fill parameter or pattern of all of the elements to match with the colors that is defined in the dictionary. And finally, we're calling this view to the user, so he's going to see this, and then we're going to clean the temporary file and delete it. And this is the class that is responsible for updating the coordination view. At first, we are identifying or getting the UI application, UI document, and the document itself, and we are then trying to look for a coordination view. If there isn't, then we tell the user that no coordination view is there. Go create a new one or a coordination view first, and then come to update it. Else, we are going to use the try method also to catch any error, any unhandled errors. And inside this, we are gonna use a custom function that we created, which is the are all elements correctly colored or not. And this function actually is simple. It takes the document, the string parameter, the dictionary, which is consists of also, the string value of the status code themselves and the color values assigned to everyone. So if there isn't a coordination view, we're going to return false. Otherwise, we're going to use our dictionaries to test if the parameter with a certain value have the correct color or not. And we are actually also using this custom simple function that returns a pool value. It simply compares between the orange GB values of two colors. We're using this to identify that if there is a color mismatch, then we are going to update it. If all colors are well, so we're going to get to this. And then if elements are updated, if the pool is true, all elements are colored correctly, then all elements are already updated. Otherwise, we are going to update the elements through calling the coordination checker external command that is responsible for creating the coordination view. So we are going to update it, and a message would appear to the user and telling him update is done successfully. And this is the Excel report, the last external command. We are simply getting if or inquiring if there is a coordination view. If there isn't, we are going to tell the user create a coordination view first. Otherwise, we're going to call the Excel report, which is a Windows form that is right here. So the user is gonna choose the location and choose export. If the user chooses export, then we're gonna say we're gonna check first for the path. If the path is null or not correct, then we're gonna make a warning message for the user. Otherwise, we're gonna call the function which is export the report and give it the path. This function is actually here, so it simply calls the export to Excel function from the Revit utilities. So from the Revit utilities here, we have a lot of functions that is used in several areas of the project, but however, the main one is to export to Excel using, first of all, the file name data. We're setting the author, the title, the time, and the formatting. So each Excel file is titled by the title of the project, the Revit file, and then coordination report, and then the formatted date. And then we're using the ABB Plus library. We are calling the Excel package, and then we are setting the author, the title, the column report, and the date and time, and then we call the create worksheets function, which is here. In the create functions, we are first of all we are calling the using function because the using is for handling the garbage collection process, because this is an external command to the .NET framework. So first of all, this region is responsible for creating the maturity level worksheet, and this region is responsible for creating the charts sheet. The file consists of two sheets, and then we're going to save the file, also using the try and catch method. First of all, the create maturity level sheet. We are setting the sheet name, adding the title and the project info, which we get from the custom function here. We are setting the title of the report and getting the required info and making them to be more of formatted in a formal way, like we're going to see in a few minutes. And then we are setting the header of the first table, consists of the category, family type, element name, and element parameter, and then we are formatting the header. Then we are defining the status code and retrieving all the elements and group them by the categories. And this is important because this allows the user to have a formatted Excel sheet that is easily readable. And then we are writing the grouped data to the worksheet and merges the cells for the categories, because if we don't do this step, then all of the categories would be like all elements would have does already have a single row. So in each row the category is written. So we're going to merge the rows with the same categories to make it more readable also. Simple playing with the Revit or the Excel sheets, and then we're going to create the charts as well, adding the title and the project info at the beginning of the worksheet to make it more readable and for the users and more ready to be shared. And then we are going to define the status color also, calling these functions regarding the play with colors, because and this is actually important. I'm going to explain it in a minute. However, but we retrieve the elements and group them by categories and status codes also, and then write the group data to the worksheet, and then we do two charts, which is the pie charts and the bar charts, pie and bar charts. Okay, so and then we save the files. All of these functions regarding converting colors to the system drawings colors, or to the Revit colors, or etc., or to colors themselves, because .NET Framework has a class called color, and we are dealing with two programs here, the Revit and the Excel. So we use the convert to system drawings color whenever we're trying to export to Excel. It simply takes the dictionary that we created. It's a general dictionary, just the strings and the colors, which is here. No, it's in the Revit utilities. Yeah, we are in the Revit utilities. Okay. So this is it. We are setting a simple dictionary that consists of the strings of the status codes and the colors themselves. However, we should do that to make it more compatible when trying to work with Excel. It takes the color and convert it to a system drawing color, or it takes the colors and convert it to an Autodesk colors. And also we have similar functions that are used in specific cases. For example, these functions take dictionaries, but these take only color elements, just one color element, and make it more and convert it to the Revit color. And we are also using a struct called color to make an extension for the color class or struct in .NET Framework, which is helpful in these functions as well. And then we export the file, and that is it. Okay, so this is a sample of the file. We are adding the project name and then the element maturity level report, and then we're setting the date as well. And then we're setting the main data of the project itself, the project name, number, address, client name, etc., to make it more readable. And then we are categorizing each element with the category itself. So these are the floors, the walls, the plumbing fixtures, the roofs, the topography, etc. Each one of them has the family type, element name, and element ID, and then the status code. The same goes for the next one, which consists of the same report info, and then each category is taken and telling us how many elements in each category of status code. And then we are telling the user that this represents 100% or whatever, and then we are using the bar charts and pie charts to make it more readable. Concepts are applicable and exploring more efficient ways of creating the same functions, and the Google search for looking for answers for main questions. The four main difficulties were I was faced by. First of all, .NET Framework has a definition for colors, and the same goes for Excel and Revit. So customized methods needed to be developed to ensure compatibility and to convert between the colors types. And also, not all categories were required to be excluded, were excluded easily. In fact, I had to create a hash set and put in it the categories manually that I want to exclude, because some categories like the materials, the sheets, for example, they weren't excluded by the filters that I created first. The Revit API does not allow to create specific values for the shared parameters in the form of a drop list. So I cannot ensure that there are only these 5 or 6 or 7 status code that the user should and can change between them. However, I developed a user guideline as a workaround, but I think this point needs maybe if it's truly like this, because I've searched a lot for it, then I think this should be developed in the next versions of Revit APIs. And lastly, Revit API does not allow to create a project parameter. This wasn't really a problem. I created a temporary file for the shared parameter and then deleted it. And I think this temporary file might be helpful in the future. Finally, the future enhancements. What is next? What I'm looking for in the coordination checker version 1.1, it should include two main things: the integration of Power BI platform to visualize the data in real time to the user. I want to make it an interactive platform, so it's more of giving insights more easily to the designers and not exporting the Excel files, because exporting Excel files is more of a final step that we do, but we need to visualize these data in real time. And the second thing is to explore the possibilities of integrating IFC and MVD and OpenPIM processes. I think that creating a type of view, a coordination view, and if you want to export data from this view and manipulate the data, then we should um, abide by the rules of the IFC, because these are the concepts of OpenBIM. So I think somehow there is a connection between this add-in, the coordination view checker, and the IFC and OpenBIM standards and processes, and of course the MVD. Thank you.